Good morning, everyone. I'm Saion Gupta, the founder of 10x Coder Kids and an official Guinness record holder for the youngest computer programmer in the world. And today we are going to be solving a difficult question, right, from the chapter triangles of class ninth, right. So this is not that easy. So let's see how we can solve this question easily, right? So let's start. So we have ABC, right? So ABC is a right angle triangle such that AB is equals to AC, right? So AB is equals to AC, that's given. So angle B will be equals to angle C, right? Because it's when we have an isosceles triangle, the base angles are equal, and bisector of angle C, that is CD, intersects the side AB. So first it's telling there's a bisector of angle C, so this angle and this angle are equal, and basically it intersects at side AB at D, right? Then prove that AC plus AD equals to BC. So we have to prove AC, that is a base, this side, plus AD is equals to BC. So how can we do this? When we think about it, we first what pops up in mind is using the Pythagoras theorem, but that does not work. If you try it yourself, it won't work. So what we have to do, we have to do two overall constructions in this. One is dropping a perpendicular from D to BC. So we are going to drop a perpendicular to BC. Alright, that will be our basically DE. Let's name it DE, right? So what was the use of this? Now we are going to be proving this DAC is congruent to DEC. We have to prove this. Why? So that AC we can show is equal to EC. When we show AC equals to EC, as EC is a part of BC, we are coming one step closer to showing that AC plus AD is equals to BC. So in the end, what we will have to do, I'm just giving you basically giving you a view of what we have to do. We have to show in the end EC is equals to AC and AD is equals to BE. This is what we have to show in the end, and this is how we are going to prove this question, basically solve this question. So after dropping the perpendicular, before we are proving the two triangles to be congruent, we have to note that angle B is equals to angle C is equals to 45 degree. This will be important for us. Alright, now what we can see, as this is a perpendicular, this is a 90 degree angle. So now when this is a 90 degree angle, then what we are going to do, we can see angle A is equals to angle E. So DAC, angle DAC is equals to angle DEC, right? Because both are 90 degree. Alright, next what we have angle DCE is equals to angle DCA. As CD was a bisector, so it's being divided into two equal parts. So angle DCE is equals to angle DCA, right? This is basically given to us, right? And finally, what else? Can you see it? DC is a common side, so DC is equals to DC. That is a common side. So in the end, we see that triangle DAC is congruent to triangle DEC. Right? So after proving both these triangles congruent, we can say in the side that AC is equals to EC, right? We can see that. Now we have come one step closer to showing that BC is equals to AD plus AC. But one thing is that we are not showing that AD is equals to BE right now. So we have to show that AD equals to BE. How are we going to do that? Now over here this is also 90 degree. As this was a perpendicular, both the angles will be 90 degree. Now we are going to drop a bisector over here, right? So we are going to drop a bisector over here that will divide this 90 degree angle into two equal parts, right? So it will divide that 90 degree angle into two equal parts. Let's say F. Okay. Now what can we see over here? Let's see. We have to prove that this triangle and this triangle is congruent. Now you will ask why, right? So you will basically ask why. So we know that DE is equals to AD, right? As we proved earlier that these two triangles were congruent. So DE equals to DAD, right? So when we show that this triangle is congruent to this triangle, then we will be able to show that D is equals to B. And when D will be equals to B, D is also equal to AD. So BE will be equals to AD, and then we are going to show AD plus AC is equals to BC. So let's just go ahead with this. Now that's a 45 degree angle. This is a 90 degree angle. So as this whole thing is a triangle, this is a triangle, this will also be a 45 degrees, because if this is 90, this is 45, then this will be 45. Why? Because because of the angle sum property. So basically 90 degree that was given plus 45 degree plus x equals to 180 degree. So x will be equals to 45 degree. So this was our angle x will be 45 degree. Now this is 45 and this is 45. So these two angles are 45 degrees, right? So angle FBE is equals to angle FDE is equals to 45 degree. Alright, cool. Now angle BEF is equals to angle EDF, right? So EF this is equals to angle DEF, that is this angle, right? Because this FE was a bisector of this angle, right? So that is equals to 45 degree, as it was a bisector FE, because of bisector FE, right? And finally FE is equals to FE, that is a common side. So when this happens, so through AAS congruency rule, now see, and triangle BEF is congruent to what? DEF is congruent to triangle DEF by AAS rule. And when this happens, then DE is equals to BE by CPCT. And when this happens, D equals to AD, D equals to BE, so AD equals to BE. And what do we know? BC is equals to BE plus EC, right? And EC is AC and EC is AC and BE is AD. So BC is equals to AD plus AC. So cool, guys. let's see what did we do right now. Let's go back. So okay, going back is taking too long, so let me just tell you like this only. First, we showed that this triangle and this triangle are congruent to get that this side is equal to this side, right? When we got that this side is equal to this side, we just had to show that this side is equal to this side, right? So now we know that this side is equal to this side when these two are congruent, right? So we did one more construction. This perpendicular we dropped, right? This was 90-degree, because of this was 90-degree, so this is also 90-degree. You can say linear pair, right? And then when it's divided into 45-degree and 45-degree, this is 45, this is 45, this is 45, this is 45, and there's a common side. So these two triangles are congruent by AAS. When this happens, DE is equal to BE by CPCT, and as DE was equals to AD, AD is now equals to BE. When that happens, BE plus EC is equals to BC. So AD plus AC is giving us BC, right? And I want to cut all of this because this was such a huge question and we solved it so easily. So two constructions were needed to solve this question, right? Two constructions were needed to solve this question, right? So let's just clear this up a bit. So two constructions were needed. That was this DC, sorry, this DE, sorry, DC was already given. DE was needed and FE was needed, right? So everything was related to this E point. So how to identify these types of questions, these types of constructions? When you are not able to prove anything congruent, when you are not able to prove two triangles to be congruent, like this triangle was not congruent to this whole triangle, right? It was congruent to this triangle, not this whole triangle, right? So we had to construct a line, right? So we had to make a construction over here, right? Similarly, this triangle was congruent to nothing, but we had to make it congruent, right? So what we had to do, we had to make this construction. I also tried before making this construction, but that wasn't working, so I tried the other way around and it worked. So when nothing is being congruent, then you have to construct lines, right? And you have to basically hit and try with it, right? So we just smashed this question and I hope you like the video.